All right, let's talk about Coulomb's law. Coulomb's law is the equation F equals K Q1 Q2 over R squared. Hopefully, this reminds you of earlier when we talked about the universal law of gravitation, which was F equals big G times m1, m2 over R squared. It should look a little bit familiar, but now we're talking about charged particles. So instead of only having attractive gravity, right now we have charged particles that can either attract or repel. So before we even use the formula, we're going to consider our situation. We're going to look for positive and negative signs, and we're going to say opposites attract, and then likes repel. After we use the signs to figure out if we have attraction or repulsion, then we're going to take the quantities and plug it into the formula to figure out how much it's going to either attract or repel. Inside the equation, K is for constant, right? And that constant is Coulomb's constant. So K is equal to 8.99 times 10 to the 9 Newton meters squared per Coulomb squared. And it's the same every time, it's constant, right? Q1 and Q2 are the magnitude of the two charges that are interacting, and R is the distance between them. So one of the problems in the activities, one of the activities that you have on Edgenuity looks like this. You've got 3 charges, and they're in a line. Whoops, sorry, that was supposed to be a straight line. Bad things happen. My paper kind of wrinkled there. So you've got one charge, which has positive 6 coulombs, and that one's 2 meters away from another charge, which is negative 4 coulombs, and that guy's 1 meter away from a final charge that is positive 3 coulombs. And the problem asks you, what is the force between charges 2 and 3? Well, so when we look at 2 and 3, we see 2 is negative 4 and 3 is positive 3 coulombs. So we see that they're opposites, and so we know they're going to attract. So we know that the force between them is going to be pulling them together. So how much? How much will they pull together? That's when we need to use the formula. K is for constant, so we're going to bring down 8.99 times 10 to the 9 Newton meters squared per Coulomb squared. Charge 2, we're going to drop the negative. We use that to figure out the direction. We don't need it for the formula. 3. And then the R in the denominator is the 1 meter that separates them, the distance. That's a nice number to have in the denominator because it divides away. So let's get out the calculator. 8.99 times 4 times 3 times 10 to the 9. You can see I saved my exponent for last because I don't want that to screw anything else up. So I have 1.1 times 10 to the 11. Now, in the answers in your program, you will see that this is a negative number. Why is it negative? Because of the direction. It's going negative direction in the number line. So negative 1.1 times 10 to the 11 is the best answer.